Hello class, welcome to our session today. Thank you for watching the previous videos. Last time we talked about integration by substitution, trigonometric functions. So I have given you two examples, and those two first examples, as you have noticed, there was only one substitution happens. But this time, for this third example, I will show you that this involves two substitutions. Okay, so our given is the integral of cosine 3x divided by sine squared 3x dx. If you examine the given, it's different from our two previous examples. So this time class, since we cannot figure out what steps that we need to do following the first two examples. So this time we are going to use substitution or do substitution immediately. So from the given, we can let u be equal to 3x. Okay, so if we let u equal to 3x, then we can solve for dx from this. So we can express the whole thing here in terms of u and du. So finding the derivative of u with respect to x, so this is equal to 3. Okay, or to solve for dx, so you cross multiply this, divide both sides by 3. Alright, we'll do the same as what we usually do. So multiply both sides by dx or cross multiply dx, so you have 3 times dx. Right, since we let u equal to 3x, so our integral now becomes integral of, so this becomes cosine u, okay, because we let 3x equal to u, so this is now cosine u divided by that will be this will be sine squared u. Okay, is it clear? And then we are going to replace dx. So we replace dx, this dx here, with expression that contains u. So from here we have du equal to 3 dx. So solving for dx here, so we can divide 3 both sides, so that we have du divided by 3 equals dx. So our dx now, we replace dx in terms of du, where our dx is equal to du over 3. So we can substitute this one here. Okay, so instead of writing dx, but our dx is equal to du over 3, so we can rewrite this as du divided by 3. Okay, so we can also rewrite this as integral of cosine u divided by sine squared u. Then du over 3 is the same as 1/3 du, right? So they're just the same. Then putting this constant on the left side of the integral sign, so we have 1/3 times the integral of cosine u divided by sine squared u times du. So are we now in the form of our general power formula? So you may check. So not yet, but it's almost. So we have to manipulate this in such a way that we can produce this form so that we can use this formula. So how are we going to do that? So the given class can be written, this result can be written also as 1/3 times the integral of, this one can be written as cosine u divided by sine u to the power 2 times du. From our trigonometry, so this expression is just the same as this. So from here, we can also rewrite this as, you can bring this up. So this will be sine u raised to a power -2. So when you bring this up, so the exponent becomes negative. So times cosine u times du. Okay? So if you look at this, it's almost the same as in our general power formula. Okay, so it's now in our power formula almost. So what we are going to do now is we are going to do another substitution. Okay, so doing another substitution here, so we will use another variable. So we can using another variable, since we have used already u, so we have to use v this time. By the way, class, from this, our n is equal to 2. Because as I mentioned, you can get the n as the exponent of the expression outside the parenthesis, like this one. So n is equal to -2. Sorry, this is -2. So our n plus 1 here is equal to, what is -2 plus 1? So this is -1, right? Okay, I will rewrite it below so that we can save space. So from here, our n is equal to -2. So our n plus 1 is equal to -1. Alright? So here we can let another variable to represent this. So we can let v, okay, v equal to sine u. Now, finding the derivative of v with respect to u, so we have derivative of v with respect to u. So this is equal to, so we will use the formula of the derivative of sine. What is the derivative of sine? So the derivative of sine, so from our formula before, we have derivative of sine u with respect to x is equal to cosine u times the derivative of u with respect to x. Okay, so I hope you still remember that formula. So therefore, derivative of sine u is just cosine u, okay, then times the derivative of u with respect to u, so it will happen du over du, right? So du over du, which is equal to 1. Okay, so this will be equal to 1. So therefore, our dv over du is equal to cosine u. Or solving for dv. So we have dv equal to cosine u du. Alright? So from here, since we let v equal to sine u, so we can rewrite this as v, integral of v, because we let sine u as v. So this will be integral of v raised to a power minus 2. Okay? Then times, what is this? Cosine u du. So because we have to replace this also, because we have v now, so it must be a dv, or contains the dv. But we have solved this cosine u du, which is this one, equal to dv, right? So meaning this one equal to this one, which is equal to dv. Okay, so substituting, so our integral function now is integral of v to the minus 2 times dv. Okay, so as you can see, it looks like this one already. We have u to the n du, but we have v here, v to the n dv. So therefore we can use this formula. So using that formula, so we have the formula is u to the n plus 1. Okay, u equal to n plus 1. Now we have v, so this should be v to the n plus 1. So it means that v to the n plus 1, where our n plus 1, we have already solved this or identified this. N plus 1 is equal to minus 1. So this is minus 1 divided by n plus 1, it's also negative 1, then plus c. By the way, class, we forgot something, no? Because we have 1/3 here. Okay, so we have to write that 1/3 also. So sorry, I forgot the 1/3 here. Okay, I will rewrite it. So from here, sorry, I forgot to write 1/3. There's a 1/3 here. So this is 1/3 integral of, we let this equal to v. So this is v, then the power is minus 2. Then times this one, cosine u du, which is equal to dv. Okay, this is it. So applying the formula, because this is now u to the n dv, but we have now v and dv, so v to the n dv, so it should be v to the n plus 1. So 1/3, so this will be v to the n plus 1, but our n plus 1 is equal to minus 1, divided by minus 1, then plus c. Or this is equal to, sorry, I have to rewrite this. So this is 1/3. Okay, so 1/3 times negative 1, so this is still negative 1/3. Then times v to the minus 1 plus c. Then from the low exponent, you can rewrite this as 1/3 so this v to the minus 1 can be written as 1 over v to the positive 1, no, from the low exponent. So equal to minus 1/3 times 1 over v, where what is our v? Our v is equal to sine u. Okay, so this is 1 over sine u, then plus c. But from our trigonometry, from our trigo, you have 1 over sine theta. So 1 over sine theta is just cosecant theta. So we have to make use of that identity. So this can be written as minus 1/3, negative 1/3 times 1 over sine, that is cosecant. So this is cosecant u, then plus c. Okay, so are we done? So not yet, no? Not yet, because we still have u. So we have to substitute. Here we did the first substitution by substituting the value of v, which is equal to sine u. Now after that, we have to substitute the value of u. So what is u? So our first substitution, we have u equal to 3x. So we have to bring back that to x. So this is 1/3. Okay, 1/3 times cosecant, negative 1/3 times cosecant 3x, then plus c. Okay, so I hope you can still see it. Alright, so this is our final answer. This is 1/3 cosecant 3x plus c. Okay, so that's it. So thank you very much. I hope you're able to follow this. So this is an example of integration by substitution for the trigonometric functions. Then we did 2 substitutions here. Okay, see you in our next video. Bye.